Hi everyone. In today's video, I want to talk with you about a question that is frequently asked, but also interesting around JWT token. That is, how is JWT token secured? If you use JWT token for a while, soon enough, you're going to realize, oh, JWT token is base 64 encoded. That pretty much means you can just decode the JWT token and you can see the clear text on it. Let's see an example. Let me start by getting a JWT token. This JWT token is generated by an ASP.NET Core server that I created in the other video. If you are interested in how to get one by yourself, check out the link on the right upper corner. The token at this moment is not readable because it is encoded. Let's decode it. Go to jwt.io and just paste in the encoded JWT token. The token have a header as in red, and the payload as in purple, and then a signature as in blue. The interesting information like the current user or the role the user is in or the issuer audience of the JWT token are usually on the payloads. Now the question is, since these are clear text, how does the server know it is not tampered when it is received? Before I answer the question, let's think about a scenario in our real life. For example, your information on your ID is clear text, like your name, date of birth, things like that. When you show an ID, how do we know it's not a forge? The answer could be there's a watermark on it, or someone signed it, meaning there's always something to show the integrity of the piece of doc. Coming back to the JWT token, that part that ensures the integrity is called the signature. Okay, but what is a signature? Why would it work? To explain that, let's take a look at the code. What you are seeing here is the creation of a JWT security token that is used in the other video. From this code, we know it takes in information for the payload, it takes in a key for signing, but it doesn't tell us how the signature is generated. So let's dive deeper. This code does the same thing as it was before. It's more detailed on how to do it. At the beginning, it takes in a header and a payload, and it gets the base 64 encoder of them. On line 17, it put together the encoded header and encoded payload and format it up as a digest. So digest is a combination of the header and the payload. Line 18 supplies a key that only the server knows, just like it was before. In the using statement next, the HMAC takes in the key as a parameter and computes the hash of the digest. The output is a signature. So let's clean up the logic here. The digest plus the key decides the signature. And digest is a combination of header and the payload. And that means it is the header, the payload, and the key putting together to decide the signature. And since it is a hash, we cannot reverse computing it. That means we can always use the digest plus the key to generate the signature, but not the other way around. On line 29, we output the result in form of a JWT token. Let's run the code and get a token. I'm going to copy this piece of token and decode it. So also 3 parts, the header, the payload, and the signature. At this moment, you probably notice the secret or the key actually is missing from the information. And that is unpurposely left out. That if the client try to tamper the content of the payload, for example, change the username from SAR to admin, well, they would not be able to run the hash algorithm using the same key, and it will lead to the signature mismatch. This is just like if you try to tamper some information on your driver's license, for example, you're going to break the watermark. Let's note down the signature here and assume the tampered JWT token is sent back to the server. Once the server gets the JWT token, the first thing it's going to do is to recalculate a signature using the header and the payload. Let's say the username on the payload has been tampered to admin. It will use the header, the payload, and the key that it owns to calculate another signature. And it will quickly find out the signature on the token that has been passed back and the signature it calculates through the key is different. And that's when the server knows not to trust the information on the payload, like the username of admin. Okay, let's come back to the question at the beginning. If you can decode a JWT token, how is it secure? Well, on the client, you can get clear text out of the decoded token for header and body, but you cannot change it because it is signed by a private key that only the server knows. Think about your driver's license. It has your information clear text like name and the date of birth. With the information withheld by the DLL, you don't know how to create a proper watermark for it. The server checks the signature just like the DLL would check the watermark. In case of the signature matches with each other, the server knows the information on the payload is trustworthy. On the contrast, if the signature doesn't match, the server would know not to trust the information. And that is why, even though the payloads are clear text, the server still knows whether it's being tampered or not. That's the security. Thanks for watching. I wish you enjoyed the video. Please comment below to let me know what you think. And if you like the content, please don't forget to like and subscribe. I'll see you in the next video. Until then, take care.